Hello and welcome back. We will continue looking at exponents and we'll finish up with roots. These are specifically non-integer exponents. So when I write b to the 1/nth power, I can also write this as the nth root of b. What this means is the number such that when you take the nth root of b to the nth power, you get b back. So when you look at this right here, this should remind you of the power rule. So if we go back to the power rule, what this says is that if you have an exponent to an exponent, you're actually going to multiply the exponents together. So when you take b to the 1 over n to the nth power, well, 1 over n times n is just 1. So everything cancels out here. So b to the 1 over n to the n is just going to be b itself. So if we were to take the square root of 4, note that if we're looking at the square root, we normally just drop off the 2 off of this. So this is just going to be the same thing as 4 to the, see here, I don't want the parentheses, 4 to the 1/2 power. This is just going to be 2, because 2 times 2 is 4. Now, you could go, but Casey, there are multiple numbers that when you multiply together, you can get 4. For instance, -2 times -2 is also 4. So why isn't the square root of 4 2? Well, in mathematics, we really want to be precise. So this symbol here, this square root of 4, and also 4 to the 1/2, we want to make a choice, and we only want this to be one number. If we're taking an even root of a number, and the number that we're taking the root of is positive, even though there will be two options, there will be a positive and negative option for the root, we will always use the positive one. So the square root of 4 is 2, even though -2 times -2 is also 4. Sometimes, when we look at a question, when we look at some roots, there might not be an answer. So, for instance, here we have the square root of -4. Well, it turns out that no number times itself is negative. If you take a positive times a positive, it's positive. If you take a negative times a negative, it's also positive. And 0 times 0 is 0. So nothing gives you a negative number. This does not exist. If we were to use complex numbers, as in imaginary numbers, we could write down a symbol to represent the square root of -4. In this class, we're not necessarily going to use that very often. So for the moment, we'll just say that this does not exist. So let's just do some more examples of roots here. So the third root of 8, or 8 to the 1/3 power, here what we're doing is we want to know the number so that when we multiply it by itself 3 times, we get 8. It's going to be 2. And again, one way to see this, if I take 2 to the 3rd power, I get 8. So if I take 2 to the 3rd power and I raise that to the 1/3 power, whatever I do to one side, I have to do to the other. So when I take both sides to the 1/3 power, well, 2 to the 3rd power to the 1/3 power, and when I multiply those, I just get 2. So this is how I might work this out. Now with roots, we might get something like this. The cube root of 24. Well, when we look at the cube root of 24, if you were to think long and hard about this, you'd see that there is no nice number, such that when you multiply it by itself 3 times, you get to 24. 2 times 2 times 2 is 8. 3 times 3 times 3 is 27. So the cube root of 24 is going to be somewhere between 2 and 3. And it's not going to be a nice number. However, I'm going to simplify this in the following way. 24 is in fact 8 times 3. And I'm going to use a trick here, which is we can do the following. I can take the cube root of 8 times the cube root of 3. And we already saw what the cube root of 8 is. This is 2, so this is going to be 2 times the cube root of 3. Now the question is, why can I split this up? Well, for the same reason that we can distribute powers. So if you remember from the last video, if I take a times b to the nth power, I get a to the n, b to the n. This works for not only for integer powers, but also for fractional powers. So like here, if I have a times b to the, in this case, this is the 1/3 power. This is the same thing as a to the 1/3 power times b to the 1/3 power. So instead of writing 24 to the 1/3 power, I can write it as 8 to the 1/3 power times 3 to the 1/3 power. So we can pull apart radicals, we can pull apart exponents like so. And then what we want, typically what we want, is so that there's nothing else that we can pull apart, and what's left under the radical sign can't be pulled apart anymore. All of the factors of 3 are just 3, so there's nothing more I can really do there. Lastly, we've got the 5th root of x squared. So with this, again, there's not a whole lot I can do to simplify this, except I can turn the 5th root into an exponent. And here, when I look at this, I have x squared to the 1/5 power. Oh, this is the power rule again. If I have an exponent to an exponent, I can just multiply. So 2 times 1/5, that's just 2/5. This is going to be x to the 2/5 power. Simple. So then this is going to be as simple as I can make this. There are a couple things to keep in mind though. Let's look at this example here. I've got the square root of -7 squared. Typically, when we think of square roots and squaring something, they undo each other. So it's really tempting to say, if I take the square root of a square, they just cancel out and I get -7. This is not the case though, and we need to be careful. So I want to do this step by step. Notice that if I square the -7 on the inside, -7 times -7 is 49. And the square root of 49 is 7, because it's always positive. So we do have to be careful here. Also, if I look at this, if I take the square root of x squared, again, what I kind of think I want is x, but it's not exactly right. Why? Because the square root of a number should always be positive. X might not be positive. How do I make x positive? You add absolute value signs. So if I take the square root of x squared, I'm going to get the absolute value of x. Now, if a question says that all variables are already positive, then for instance, I can just write the square root of x squared as x, because if I know that x is positive, the absolute value of x is just equal to x, and I don't have to do anything. So if x is positive, let's see here. So if x is positive, then I don't have to write the absolute value signs. If not, the absolute value signs are necessary. So this would be if x is not specified. So we do have to keep in mind the fact that square roots need to be positive. If there's a chance that you could get something that's not positive, we add absolute value signs and make it positive. And this is a very, very quick summary of exponents. I'm hoping that this is mostly review. If not, come and talk to me and we will get it figured out.